Okay, YouTube, in this last video we're going to continue solving linear systems in which we have two equations and two variables, but we're going to look at systems that come out to have infinitely many or no solutions and what that looks like when you solve them algebraically as opposed to graphically. Of course, we know that if a system has infinitely many solutions and it's a linear system, then that means that the two graphs of the two lines must have overlapped at every single point. Or if we had a system that had no solutions, we had two lines that were parallel to one another and share no common points of intersection. But algebraically, what does this look like? So we're going to consider these two systems that I see down here, and we're going to choose a method for solving them. Now, we could either use substitution or elimination. So how about with this first system here, we'll use maybe substitution. And I think that it would be really easiest to get this y by itself in this equation. So if I said, well, let's do this. We say 2x minus y is equal to 3. If I were to put the 2x on the other side, I get negative y equals 3 minus 2x. And if I take everything times a negative 1, essentially, what's going to happen is everybody's going to switch their signs over. So we basically get this. This is our revised equation. I'm going to rearrange things here. I get y equals 2x minus 3. This is the same as the second equation, but we have y isolated. And the reason why, excuse me, that's important is because now what we're going to do is we're going to go substitute that into the other equation. So now we come up with this. We'd say this statement, 4x minus 2y equals 5, now becomes the statement 4x minus 2 times y, which is the same as 2x minus 3. Go plug that in there, 2x minus 3. We can now go isolate for x here. We've only got x's left. So we say 4x minus 4x minus a negative, well, this would be a negative 2 times up negative 3. I guess it'd be a positive 6 equals 5. The idea is that when we do this, you notice that your x's cancel out completely. And you haven't done anything wrong if this happens. As a matter of fact, you should get really excited if that happens because one of two things must be true. If the x cancels out, then it means that these lines cannot cross at one and only one point. They must either cross at all points or cross at no points. So because we get a false statement, 6 is never equal to 5. This is never true. Then what we have here is a set of, when we graph these, parallel lines, okay? And they must be parallel lines because they can share no point of intersection. And basically we would say that the system has no solutions because we got a system, well, we got an algebraic result that is never true, okay? So if you get a never true result, then graphically you must have parallel lines, and algebraically we say that these will never cross, so have no solutions to the entire system, okay? They have their own solutions, but no solutions to the entire system. This equation here, I'm kind of, now that I notice that all of the variables here have non-1 coefficients, I'm kind of inclined to use the elimination method. And if I had to choose one of the variables to eliminate, well, you know, negative 3 and positive 4, I bet you I could make those both 12, one positive and one negative. So what we'll do is this. We'll take the second equation here times a positive 3 to make this a positive 12x. We'll take the first equation times a positive 4 to make this top x value here a negative 12x. So rewriting this system, we get negative 12x from the top equation. This would be plus 24y's, and this is equal to, now 4 times 9 is 36. Likewise, if we distribute this 3 through the second equation, we get a positive 12x. 3 times a negative 8 is negative 24y, and this is going to be equal to 3 times a negative 12, which is negative 36. I don't know if you see it already, but when you add these up, check it out. Both sets of variables cancel out, and we're left with 0 on the left side. But not only that, you get the right side to cancel completely. You get 0 equals 0, which is true. It's always true. True always. So if we get a result like this, what this essentially means is this. These must have been the same line in the first place if they cancel out perfectly with one another. And when you have two lines that are the same line, how many points at which they intersect is infinitely many, So we say we have infinitely many solutions if you get an always true result. So infinitely many solutions in this system here.